How's it going? Welcome back, guys, all the tech enthusiasts out here. Today we will talk about one more interesting paradigm, which basically combines two major paradigms that we already talked about. And those two paradigms are single board computers and clusters. So what do we get now by combination of those two? Single board computer clusters. So let's talk about single board computer clusters. And I do want to apologize for the muffling of my voice. I am pretty sick today, but I do still have to provide this necessary information to my audience. So without further ado, let's continue the video and let's talk about single board computer clusters. So then the question arises in all of your minds, what in the heck even are these single board computer clusters? Well, to make it easy, unlike traditional clusters that occupy entire data centers, SBC clusters offer a more compact and scalable solution. But before we deep dive, let's rewind and explore the roots of single board computers. From the Altair 8800 to modern marvels like Raspberry Pi, single board computers have undergone a remarkable journey of innovation and advancement. Each milestone in SBC history has concluded to the development of SBC clusters, shaping their capabilities and potential applications. But anyways, jumping from the SBCs, let's talk about SBC or single board computer clusters. And let's shine a spotlight on some of the most notable SBC clusters that exemplify the versatility and power of this computing paradigm. At the forefront of it all is the Turing Pi cluster that I myself use while doing my research on the single board computer clusters, and that is essentially a testament to the power of Raspberry Pi clusters in real-world applications. This Turing Pi cluster is designed with the scalability and flexibility in mind. This innovative cluster allows the users to effortlessly build and manage Raspberry Pi clusters for various computational tasks. So what do we got? A Turing Pi board or Turing Pi cluster, and I can show you guys in the link down below in the description on how to buy that, where to buy that. So this is the Raspberry Pi cluster on the Turing Pi board. We have compute node 1, 2, 3 and the head node right here. And if you guys want to learn more about the Turing Pi cluster, because it's a topic of its own, please leave a comment below. And also, if you want this channel to grow, I will beg for likes and subscribe once again, because that is how I can provide you guys more and more videos. So please give me a subscribe. Anyways, moving on from the Turing Pi clusters, we have RISC-V clusters that represent a cutting-edge approach to cluster computing, leveraging the open source RISC-V instruction set architecture to drive innovation and collaboration. With the unprecedented levels of performance and scalability, RISC-V clusters are at the forefront of redefining the future of computing. But I don't want to spend an entire video talking about the RISC-V and its complexity, because it is one of the more complex single board clusters to set up, and that will be a topic of a future video. But let's talk about something else that is also a notable example of single board computer clusters, and that is the cluster made out of the x86 architecture. And I also worked with that as well in my research, and I can show you guys actually that in the future. It is a really nice box, you know. Basically it's like a size of a, I guess, size of a GameCube, if you guys know what that is. I mean, even and I'm 27 right now, I was like 12 when GameCube was a thing. I'll show y'all our x86 clusters I talked about, that I told y'all looks like a GameCube. Look at this. We got the power strip, we got the power supply here. We got 4 x86 single board computers. You have in these x86 computers, you guys have the USB 3.0, there's the HDMI, there's the aux cord, and then there's USB 2.0 right here. And I can show you guys this more in detail in the future, but right now just showing the assembling of the x86 clusters. I mean, it's already assembled. Maybe in the future I can like make one like that, you know. If you guys want a detailed video on the x86 clusters, let me know. Here we have the local area network, and each 4 nodes are connected right here on these Ethernet ports. That is how the cluster actually works. Multiple nodes or multiple computers connected over the high-speed local area network. And then here each 4 x86 single board computers act as nodes, like I said, right? The 3 at the top, like this, and this, are compute nodes, and the bottom one is the head node. And now we have to explore what essentially gives the single board computer clusters an edge over traditional computers, or even like an extremely powerful gaming PC, because y'all must be asking, why go through all the trouble of finding the Raspberry Pi, the Turing Pi board, building that? What does it give us? What is the edge? Well, one thing is obviously the cost effectiveness, because a traditional cluster that encompasses the entire data center costs millions of dollars just to lease or rent, perhaps $50 to $100 million to actually buy one. But a Turing Pi board with, let's just say, 5 nodes and a head node would cost you $300 to $400 in total, which is still a lot cheaper than even the high-powered gaming PCs that can go up to like $2,000 to $3,000, so even more depending on like what kind of graphics card you guys want, how much processing power, how much RAM. And then we cannot talk about the advantages of clusters and cluster computers and not mention the scalability. Just like traditional clusters, even the single board clusters have horizontal scaling support. We can add more and more and more nodes. You can even incorporate a Turing Pi board with a different board of Raspberry Pis. You can have 10 nodes, 20 nodes. The horizontal scaling of adding more nodes is a lot more effective than adding more processing power to a traditional gaming PC, because that can be a lot more cost inducing. The energy efficiency is inherent to the design of single board computers, which are typically optimized for low power consumption. By leveraging energy efficient components and streamlined designs, SBC clusters consume less power than traditional clusters or high power personal computers like high-end gaming PCs that I've been talking about. This not only reduces operational costs but also minimizes environmental impact, making SBC clusters a sustainable choice for long-term deployment. One major hallmark of single board computer clusters is versatility. Because of their compact form factor and diverse range of applications, the SBCs facilitate edge computing, IoT devices, educational projects, and research initiatives. SBC clusters can adapt to a wide range of use cases with minimal customization. This versatility enables users to explore new applications and experiment with the innovative projects without being constrained by traditional computing limitations. And lastly, accessibility is a defining characteristic of SBC clusters, democratizing high-end performance computing and making it accessible. So now the most logical question that should be coming in your heads is that, okay, we learned about SBC clusters, we learned about its history, but why should we care? Why is it important? Well, if it indeed does, then let me answer that question. One notable application of the SBC clusters is in the field of data analytics and data processing. SBC clusters can be deployed to analyze large data sets, perform data mining, and machine learning algorithms. Their scalability and cost effectiveness make them an attractive option for organizations looking to leverage big data analytics without investing in expensive infrastructure. For example, if you want to build a humongous data center with the hundreds of thousands of nodes which could be used in the massive data processing, it also costs millions of dollars. And SBC clusters that can do some low-level data processing can be made in a few $100s, so a lot more cost effective for small organizations with relatively small data sets and not, a few petabytes. Another key application is in the educational setting. SBC clusters provide an accessible platform for teaching and learning parallel computing, distributed systems, and network architecture. Students can gain hands-on experience with cluster technology, exploring concepts such as load balancing,
fault tolerance, and parallel processing in a practical environment. Now, SBC clusters and its uses cannot be mentioned without mentioning the scientific research, the core of it all. SBC clusters are used in scientific initiatives across various scientific disciplines. Researchers can harness the computing power of SBC clusters to simulate complex systems, conduct computational experiments, and analyze scientific data. The data that range from climate modeling to bioinformatics to astronomy to physics to quantum mechanics to string theory, you name it, any kind of set to do research on, SBC clusters can play a humongous factor in facilitating that. Additionally, SBC clusters are deployed in edge computing environments to process data closer to its source, reducing latency and bandwidth requirements, which makes them the ideal tool for applications such as IoT, Internet of Things based devices, smart sensors, and real-time monitoring systems. By distributed computing resources at network edge, SBC clusters enable faster decision making and improved efficiency in IoT deployments. And lastly, but not the least, SBC clusters are used in prototyping and development projects, allowing engineers and developers to test and iterate on software and hardware designs. Whether it is building a prototype for a new product or experimenting with novel computing architectures, SBC clusters provide a flexible and cost-effective platform for innovation and experimentation. In conclusion of this section, the versatility and adaptability of single-board computer clusters extend beyond traditional computing paradigms, finding applications in data analytics, education, research, edge computing, and prototyping, as I already mentioned. As technology continues to evolve, SBC clusters will continue to play a vital role in driving innovation and addressing computing challenges of tomorrow. And well, if you have somehow managed to make it this far, and you like what I do and you want your own, not just mine but also your own channel to grow and become more and more improved with better equipment, please support me by giving me a like, a share, and subscribe to the channel. Until the next video, have an amazing day.